Dry land salinity. It's a significant problem that's been impacting West Australian agriculture for decades. Over time, three main solutions have emerged to address the issue, with a multifaceted approach working the best. One solution utilises shrubs and perennial pastures for grazing, while another involves undertaking revegetation for land restoration and biodiversity. The third solution, which this video focuses on, entails implementing engineering solutions, including surface water control measures and groundwater systems. It's worth noting, though, that such engineering solutions tend to be expensive and take a long time to yield results. How effective a groundwater drain is as a salinity mitigation solution varies from site to site due to a number of factors. For example, the effect a drain has on the water table decreases as you move away from the drain. This phenomenon, known as the drawdown effect or zone of influence, is dependent on soil type and its permeability and capacity to leach accumulated salts, the drain depth and its ability to intercept groundwater and lower the water table, and the recharge rate, or the rate the groundwater is being replenished in the water table. To help gain a better understanding of groundwater drainage, an independent review on drainage research in WA was conducted by GHD in 2017. This review concluded that single drains have limited effectiveness in lowering water tables. And for a drain to be effective, a good understanding of soil properties, the water table depth and lateral flow rates is required. The review also identified that the impact of a drain needs to be evaluated in the context of any downstream effect on the receiving environments. This would come from the quantity and the quality of the water being discharged, including its acidity. When trying to control salinity by installing groundwater drains, the main purpose is to intercept and lower the water table, reduce waterlogging, and reduce the surface salinity levels that occur in the valuable topsoils. For someone like a farmer, this means potentially rehabilitating their marginal land and preventing further loss of the productive agricultural land they have. To ensure their groundwater drains can be effective, it is crucial that landholders conduct a thorough site assessment prior to constructing a drain. By doing this, a prudent landholder can evaluate the unique characteristics of their land, minimising the chances of any surprises or extra expense when constructing a drain or undertaking any other type of salinity mitigation. Once a landholder has carefully evaluated all salinity mitigation options, their advantages and disadvantages, and ultimately decides to intercept saline groundwater to install a drain, it is vital they utilise the Notice of Intent to Drain process. This legislation guides the landholder's proposal and includes detailed information about the groundwater drain, including any negative impacts the discharge may have on downstream receiving environments. The Department's John Firth has been involved with groundwater drainage since the 1980s, and he works with landholders to ensure their drainage proposal is sound and that it complies with the legislation.
When a person is wishing to construct groundwater drains, there is a legal requirement they must follow. A person has to submit what's called a Notice of Intent to Drain at least 90 days before they plan to construct the earthworks. That Notice of Intent to Drain will contain quite a lot of information about the proposal. It will contain details such as the location of the drain, the length of the drain, the actual physical shape of the drain, the design of the drain, We also will find out if there's going to be any levees on the drain and any plans for controlling surface water. At the same time, they can actually put in any information that they have regarding the test pits. It could be the water level in the test pits, it could be any salinity readings they have in the test pits, or any other relevant data that they may have regarding to groundwater tables. And this could be as simple as knowing what depth of water is to a windmill that's in that area. Another part of the notice of intent to drain is that we do ask the landholder to communicate with at least the next two downstream neighbours. This is important so that the neighbours are aware, and also to ensure that they have the correct concept of what that person's trying to do.
Yeah, and so does that have a batter on it, does it?
If a person has any issues with that drain or the proposal, they can put that on the what we call the neighbours comment form and send that information back to the Office of the Soil and Land Conservation Commissioner. Once all that data has been collected by the landholder, then they'll submit the entire application to the Office of the Soil and Land Conservation Commissioner. As well as the groundwater drain.
Okay.
When I'm talking with landholders where they're thinking about doing drainage works, or they've got their application in, they've lodged a notice of intent to drain, or it could be at a field day, or just a general conversation with farmers. One of the things, in order to keep things simple, I talk to them about what I call brownie points. This is where I say if you want to construct groundwater drains, these are things you must do. First of all, you have to put in a notice of intent to drain. That's the first brownie point. The second brownie point is part of your design has to include double levees on both sides of the groundwater drain to actually keep the surface water separate from the groundwater. One of the other major considerations I ask landholders to engage in is constructing test pits. The next thing we need to look at is where you're going to discharge the water and to communicate with at least your next two downstream neighbours. By following this, what I call a brownie point rule, is a greater chance that your proposal will be accepted.
Installing a groundwater drain, conducting the site assessments and the earthworks itself is a big undertaking, and landholders need to find out as much as possible before proceeding. To help people gain a better understanding of the procedures involved in planning, construction and monitoring of drains, a groundwater drain demonstration site has been constructed at the Katanning Research Station. In fact, much of the vision you've just seen was filmed at KRS whilst making a separate video on the key principles involved in groundwater drainage. This includes using the latest drain construction techniques, surface water control measures, and how revegetation across the entire site was an integral part of the project.